Welcome to the webinar, Automated Milking System Efficiency, Balancing Focus on Individual Cows and System Optimization. My name is Paola Bacigalupo, and I am an extension educator for Michigan State University. And it is my pleasure to welcome you to this webinar where you will hear from Dr. Pablo Silva Bologna. Dr. Silva currently works as a researcher at Teagasc in Ireland. He obtained his veterinary degree from University of Chile and his PhD at University of Wisconsin-Madison. He has worked on multiple aspects of automated milking systems throughout his career. Before we get started, I'd like to share a few reminders. Please know that this webinar will be recorded. It's already being recorded, and the recording will be posted on the MSU Extension Dairy Team YouTube channels soon. And if you have any questions during the presentation, please type them into the Q&A. We will have time at the end of the webinar to go over the questions. Now I'm going to stop sharing, and please, Dr. Silva, go ahead, share your screen, and you can start with your content. You are
Sorry,
muted.
hi.
There
Yes,
you go.
I realized I was muted. Sorry. Can you see my screen okay?
Yes.
All right, very good. So I'll just start then. Thanks, Pao. Hi, everyone. Thanks for inviting me to present on this topic of efficiency in automatic milking systems, balancing a focus between the individual cow and the system optimization. So it was difficult to put this presentation together at first because I realized it's a very broad topic. Efficiency, optimization, they could be looked at in several different angles. So there's a lot of information that could be collected to prepare the presentation. And also, at first, when I thought about it, I was really convinced that there was a clear separation between, what I do at the cow level and then what I do more at the robot level to optimize the system. But then as I started digging into it and investigated a bit more, I realized that there isn't really a line that those two cross over constantly, and they're very related. So I kind of given away one of the conclusions of the presentation, but it's really balancing between the two of them, I think. So as Pao was saying, as Pao was saying, I am from Chile, in this long and narrow country here. I was born and was raised in this region, but then I moved to this region, which is the main dairy region of Chile, and I worked at Dilaval, and there I was part of the team that participated at the startup and the follow-up and the advising of the first automatic milking systems in Chile. One was a large AMS farm started off with 8 indoor robots in 8 different barns, which then became one of the largest farms in the world. And then the other one was a pasture-based automatic milking farm, which was the first pasture-based farm in Latin America, as far as I know. So I got really good learnings from that experience. Then I went on to Wisconsin to do my PhD, as Pa was saying. My thesis was related to improving efficiency, looking more so at the quarter level, so more quarter level strategies for reducing milking duration, particularly. And then I started my work in Teagasc, which is located here in Cork, the small island of Ireland. Actually, my research work now involves mastitis in dairy cows, so I've been working more so on selective dry cow therapy and other topics. But I still keep an eye on the robot work because it's really something that motivates me, and I think these systems are really cool to work with, and farmers are, when you talk to them, most of them are quite happy with having transitioned to those systems. So in this presentation, what I'd like to cover, I've done a bit of a review and data that I've collected as well on current performance of these systems, both in indoor settings and pasture-based settings. I'd like to talk about a few exercises on what's the potential performance, what can we really achieve, or can we at least potentially achieve. what factors have been identified as influencing performance, and then I'd just like to briefly touch on, empirical evidence, or what studies are there that support increases in efficiency. And I'll talk a bit about my work as well in that particular section of the presentation. So overall, you may know that robots have been around for a good while now. The first ones were installed in the early 1990s in the Netherlands. It was an indoor system, and then the first pasture-based systems were installed in the early 2000s in Australia and New Zealand almost simultaneously. So they've been around for a good while. And I was reading a paper, and they had estimated that by 2020, there was going to be an adoption of 50,000 units worldwide, mainly concentrated in Europe, about 90%. Then Canada with about 9%, and the rest of the world would be 1%. With some countries in Europe having more than 50% of their farms with automatic milking systems. Although when I was looking at Lely's website, I saw that they were celebrating the 50,000 astronauts. So it couldn't possibly be that there's only 50,000 if Lely alone have that amount. We have the other players in the market. So all put together, I think we're circling the 100,000 if we're not surpassing that amount of AMS units worldwide. That's just a very rough estimate, of course. In Ireland, there's also very little data about it, but we think that roughly 3% of the farmers are milking cows with an automatic milking system. So of a population of somewhere between 15,000 and 16,000 farms, there's bound to be around 450, 480 AMS farms, the majority of which have 2 or 1 robot, and most of them working a seasonal calving system, pasture-based, but there are other split calving systems and indoor systems as well. And this is what I was mentioning. So the good thing about this system is that they've developed into being able to be implemented in all kinds of production settings, which has made them even more widespread. The reasons for adopting can be varied, and there's plenty of literature about it. But the most common cited ones, I would say, is the labor availability, the scarceness of hiring qualified labor, and the work time flexibility as well, which makes maybe life a bit more manageable. All of that also considering that milking is a very labor-intensive task, and therefore by taking the human element out of milking, it does free up a lot of time for farmers to do other things. So there was a paper exploring the motivations of farmers in large US dairies with over 7 robots. And they did state that, labor costs, cow welfare, and herd performance was one of the main reasons for adopting. In terms of herd performance, I think the initial promise was that automatic milking systems would result in higher milk yield per cow. And this is based on the fact that, compared to twice a day milking, cows in AMS we can get more milkings per day in AMS cows, so over 2 milkings per day. Now with the very intensive and large farm setting with 3x milkings, for example, in the US, this promise of a higher output milk yield is not always realized, because it's very uncommon to see an AMS farm having an average of over 3 milkings per day or substantially over, so that it translates in more milk production. Anyway, just to cover a bit of the principles of operation, the systems rely basically on the motivations of cows to voluntarily move through the system and to arrive to the robot to be milked. This is achieved through a series of incentives, the main one being food for the cows. So that could be in the feeding, in the feeding area, or in the robot as well for indoor systems, or with the grass allocation for pasture-based systems. And there's different type of traffic configurations, particularly for indoor systems. So we have what is often referred to as free flow systems, where cows have, they have free access between their cubicles and the feeding area, and they can go into the robot if they so wish, and get milked. And it is the robot as well that decides or makes the selection of which cows need to get milked and which cows do not get milked. So this is often referred to as the free flow systems. And then we have the guided traffic systems, which usually resort to a pre-selection gate, which decide which cows will be milked or not. So in this case, this is what's called milk first, where cows are normally in their resting area, in their cubicle area, and they have to go through a sorting gate to get access to the feeding area. And if they're due for milking, they're directed to the waiting yard, and if not, they're going into the feeding area. And the other system is the feed first, which is basically the opposite. Cows are in their feeding area, and then they have to go through the sorting gate to get access to their cubicles. And if they're due for milking, they're sent to the milking area. The way that the permission is set, so we call this milking permission, it varies depending on AMS make and AMS brand, but the majority of the decision is made with on the time relative to the previous milking. So a number of hours or a minimum number of milkings per day as a target, which in turn translates of cows having permission to milk every so hours, every so many hours. And this is the way that either the robot or the pre-selection gate does the decision of which cows need to get milked or not. For pasture-based systems, it's slightly different, but not that much, but it has its own unique challenges, I suppose. The principles of operation of these types of systems is that the entire farm area, this is the map of the Teagasc AMS farm area, and it's divided into, it can be 2 sections, 2 large areas, 3 large areas, or 4 large areas, which is the 2, 3, and 4-way grazing. And in each area, a daily pasture allocation is assigned. So the fundamental behind this is that cows learn that as they start depleting the grass in one of the areas, they learn that they can go out of the area, walk towards the AMS shed. There they can get milked or not, but then they can gain access to a new area of fresh grass, and therefore this is the motivation of cows to move around the system. The sort of the promise of fresh grass in a different area of the farm. So this is usually how it works. Now, the way that we need to manage this is that we need to set a target daily dry matter intake for the herd and divide this target into the different areas. So for example, and it doesn't have to be in equal parts, it can be different. So for example, out of the total estimated dry matter intake of the cows of the herd for that day, I can assign 20% in area 1, 40% in area 2, and 40% in area 3. The important thing is that the total daily allocation of grass is adequate for the cow's requirements. Because if we assign too little in all the areas, then the cows learn that there isn't really a benefit of moving around the system, so they won't exit the paddock. But then again, on the opposite side, if we assign too much grass in one of the areas or in all the areas, then the cows don't really feel the need to leave one of the areas because they already have enough grass there. So milkings are impacted in that way. And the added complexity or detail to it is that areas open at different times of the day. So for example, if a cow is in area 2, and this area is open between 7 a.m. and 2 p.m., for example, if the cow visits the AMS shed at 11 a.m., she gets milked, she'll be sent back to area 2. This is to ensure that the grass in this area is consumed properly. Whereas if she comes in at 2:15 p.m., for example, she'll be sent to the fresh grass allocation. So those are the fundamentals of AMS pasture-based operation. But once cows arrive in the milking shed, the decision to milk can be made by the milking robot or a pre-selection gate, same as it was in the indoor system. So that part, once they get there, is basically the same thing. So just to focus a bit now on current performance of the systems, I've been looking at different papers that have reported this, both for indoor and pasture-based systems. For indoor systems, it's been reported that the number of cows per AMS, it's close to 50 or 55 cows, sorry. And this study by Tremblay surveyed a large number of dairy farms, but all of them were Lely farms. Whereas Castro, for example, had a bit of a mixture of different types of farms. But they're very similar numbers if you think about it. The number of milkings per cow per day, it was in the Tremblay study roughly 2.9. Sievert reported 2.8 milkings per cow per day, and Castro 2.7 milkings per cow per day. Now, what did I mention about which makes they were? It's not that I have anything against any particular brand or anything like that, but it's just sometimes when we have, for example, we're in Teagasc, we're collaborating with Lely in a study, and they've helped us recruit 18 commercial farmers, but you don't know if inadvertently or not, they've signaled or put us in contact with their highest producing farmers or their top farmers. So you don't really know if your sample might be slightly biased or not. So that's just to take into consideration when we're looking at the numbers of milkings per day and these performance numbers, basically. In terms of milk yield per cow per day, both studies reported roughly 32 or 33 kgs of milk per cow, and milk yield per day was approaching 1,600 or 1,800 kgs per AMS. The study of Castro, which I also mentioned before, reported milk yield per AMS per year, so that's why I didn't put it here. In the case of pasture-based systems, there's also a good few studies, a couple of studies at least, that have surveyed a number of farms, and they found roughly similar numbers. So we have Lions that report 51 cows per AMS, sorry, in 8 farms. Gargiulo reported 59, and this was a sample of farms from Ireland, Australia, New Zealand, and Chile. And the study that we're conducting, we find that the number of cows per AMS is 62 with a maximum of 79. Now, we don't know if this is representative of the industry because, as I said, recruitment occur through the company, so it might not be a representative sample of the entire AMS farms of the country, but it's good information to have regardless. The number of milkings per day, Lions reported roughly 2.4 milkings, Gargiulo 2.2, and we're very similar there as well, around 2.3 on average, but these are seasonal calving AMS herds, so the majority of milkings per cow per day, we see them in March, and this is because most of the cows are not yet calved, so the robot might be a bit understocked, so there's plenty of free time for the cows to milk. Then it drops in May and July where cows are in peak yield, and then it drops even further in September where cows are their lactation curve, or their lactation is progressing basically, and their milk yields are reducing as lactation progresses. In terms of milk yield per cow per day, Lyons et al. Found about roughly 25 kgs, Gargiulo 23, and we are finding a very similar number as well. A peak in May, which is reflective of the peak production time in pasture-based seasonal calving settings, and then a substantial drop in September then as well. And in terms of milk yield per AMS per day, we're seeing that very similar averages between the 3 studies, actually 1,200 to 1,300 kgs of milk, with a peak in our study of 1,600, and substantially lower, as you can see and as you can imagine, compared to the indoor systems, due to the lower individual milk productions of the cow, of course. So what can we really get from the robot? What's their potential performance? Now, most of the things that I'm going to talk about are theoretical exercises, and I'm not really that sure whether there's been a lot done on, empirically test these maximums or this potential. But these exercises I think are important to do because it gives us information on sort of what areas we can improve on. And I'd like to mention this particular study by Lyons and Teagasc. It was a really cool study where they looked at the average number of milkings per robot per hour of the day. So at 2 a.m., the average was around 4 milkings per day per hour. At 4, At 4 a.m., there was an average of, let's say, two milkings, etc. And what they did was they calculated the average for the entire day, and they made the following exercise. Um, if at least, if the minimum, if all the, at every hour there was at least the average number of milkings during the day, how much more milkings could we get from the system? So this means that if at 4 a.m., for example, let's say if the daily average number of milkings per hour was 5, if at 4 a.m. we will raise this number to 5, the number of milkings to 5, and while the remainder, if they're above the average, they would stay the same. And how many more milkings would we be able to get from the system? And this was considering the same, maintaining the actual milking frequency of the studied herds and the actual milk yield. So they calculated that, and they calculated also the maximum potential number of extra cows and yield that they could obtain from the robot. You can see that in the table here. On average, if if at every hour of the day there was at least the average number of milkings, you could have roughly 17 extra milkings per robot per day, which translates in roughly 7 cows in the robot, with an estimated 190 kgs of milk per robot per day. So a substantial improvement. And when they looked at the maximum, so this is, what if milking events increased to the maximum number of milkings achieved in any given day? They established that the maximum number of milkings that could be achieved during a day was 186 milkings per robot, and the robot could stock 78 cows each unit, which is substantially higher than the current average. This other theoretical exercise that Doug Reinemann did, and it looked at the effect of applying a minimum expected milk yield before allowing cows to be milked again. So here in this example, the minimum expected milk was 12 kgs or 15 kgs before cows were allowed to be milked again. And given the cow milk production rate, we're able to estimate the number of cows that could be stock per robot and the milking frequency of those cows. As you can see, the number is substantially higher than it's currently being done, but this is, of course, a theoretical limit where cows are coming in one after the other. The robot is being occupied 22 hours of the day. Box time is optimized at the maximum, so that's the time that cows spend inside of the robot is reduced at the maximum. But with these permissions, then it was estimated that the robots, and given the conditions I just mentioned, the robots could be harvesting somewhere between 3,500 kgs per robot per day, or 3.8 thousand kgs per day. And I'm sorry I'm talking in kgs, it's the only units I can really relate to. And this is almost twice as much as what we're seeing in our normal farms when we're looking at different studies and indoor systems, of course. So there is definitely theoretical potential to be achieved from the robot. Now, I ask myself these questions and without having a clear answer, but can we really get these maximal potential, extra milkings or this potential milking performance of the system with free flow systems? If part of the time that the robots are being used is occupied in the robot deciding whether the cow needs to get milked or not, is that affecting the potential maximum? But that's only when you want to reach the absolute maximum, because absolutely there's farms that are operating very efficiently with free flow systems. So in my mind, this is not an impediment or a problem for achieving high efficiency levels or high performance levels. It's just that the theoretical maximum perhaps won't be reached if the robot is deciding which cows get milked or not. And another common thing that happens is that AMS managers or farmers as well, that usually they want to allow or some free time in the robot to accommodate for certain interruptions in milking, which can be due to maintenance or breakdown. Now this, as Dr. Reinemann explained, it's a very high price to pay for an occurrence that is not quite common in the systems. Now it can happen, and it will set back the number of milkings, and it would take a number of days for cows to get back into the flow. But hopefully this will be reduced to the minimum expression, of course. So now we've established a few factors that can influence milking efficiency or milking performance, mostly looking at milk harvested per robot per day. And this is what I'm going to be reporting as well. And there are several studies that have looked into this. So for example, Castro et al. Found that the milk yield per AMS and per year could be substantially increased with an increase in the number of cows per AMS. So you can see this line here. It's a sustained increase in the number of cows per AMS. Whereas if we do increase the number of cows per AMS, there's going to be a negative impact inevitably in the number of milkings per cow per day as well. So that's important to consider. Castro mentioned that for the cohort of farms that they were studying, they could facilitate an increase of 16 cows per AMS, and this would result in an annual increase of 37% on milk yield per robot, with the concurrent decrease on milkings per cow per day of 7.8%. So there's a trade-off there, but perhaps a trade-off that it's worth it. They did mention that with achieving those numbers would result in an occupation rate, which means the time that the robot is actually being used for milking of 94%, which is very, very high levels of occupation. But they reported as well that they maximized, milk yield per AMS per year, somewhere between 2.4 and 2.6 milkings per cow per day, with maybe somewhere between 60 and 68 cows being milked in the robot. Now, they do acknowledge that some farms don't have the space to accommodate extra cows in their barns, and that's definitely something that needs to be considered. Another interesting factor that they found in their study is that the milk flow rate of the cows had a major influence on the milk harvested per AMS per year. According to their estimates, a 0.1 kg increase would increase milk per AMS over 32,000 kgs, which is an enormous amount. So this and the number of cows per robot were the two main factors that affected milking efficiency or milk harvested per robot. There's other two studies that I've mentioned before in this lecture, the one by Tremblay et al. And I don't really want you to look at the estimates or anything like that, but I just want you to focus on this square here, where I've highlighted the three main aspects that had a positive influence on milk production per robot per day, which was the number of milkings per cow per day, the milk speed, which in their study meant the average milk flow rate, and box time, so the time that the cows are inside of the robot when they are being milked. Three important factors determining how much milk can be harvested by the robot. Similarly, the study by Sievert, they found that the average number of milkings per day was also positively associated with increased milk yield in the AMS. The average residual feed, which means the amount of concentrate feed that cows are not able to eat and that is left over after they've been milked inside of the robot, had a negative impact on milk yield per AMS. Milking speed is again another factor that seems to be popping up as an important factor that's driving milk production per cow per day. And unlike the study by Castro and well, they did find cows per AMS was a significant factor, but if you see the estimates, it's not that high compared to the other estimates that I've shown you before. And then we have this study by Juan Gargiulio in AMS, pasture-based AMS, and they did a simulation analysis to evaluate the impact of changing certain variables and how would that affect milk harvested per robot per day compared to the base case. So the base case in their scenario was roughly 1,200 kgs of milk harvested with 54 cows per AMS and a milk flow rate of 1.6, and this was the milking frequency. With their model, they were able to estimate that the two variables that had the highest impact in milk harvested per robot per day was adding more cows to the robot, which in this case resulted in 70 cows, and this resulted in roughly 31% more milk, and having higher milk flow rate cows in the robot, in this case 1.98 at a stocking rate of 58 cows, and resulted in roughly 26% more cows. So this was their simulation work, and milking frequency was not that highly correlated or not that highly influential in their efficiency metrics. So they only saw like a 2% increase in milk harvested per hour per day by increasing milking frequency. But according to their simulation, this would mean a reduced number of cows, and you can see there as well a reduced milk flow rate of the cows as well. So that could be playing a role. And in this last bit of the presentation, we've looked at current performance potential and what sort of factors have been associated with performance. You can see that there are several common terms, several common factors that have been signaled, like increasing the number of cows per AMS, having higher milk flow rate cows, maybe increasing the number of milkings per day. That's kind of relative. It depends on the study. But some of these are very hard to look into in control studies. But I'm going to show you some studies regarding milking efficiency and some of the studies that I've also conducted for my PhD work and that we've done here in Teagasc as well. So some of the studies relate to the type of traffic system, both in indoor systems and pasture-based systems, changing milking permission settings and concentrate supplementation for increasing the number of milkings per day and the milk yield per day, changing the quarter teacup removal settings, and also changing the teacup removal settings of the slowest milking quarter, which was part of the work of my PhD. And what's been looked at in terms of the milk flow rate of the cows for being milked in an AMS. And there haven't been any studies more on the control side. There's more association type studies in increasing the stocking rates, but there isn't much in the sense of looking at what happens when I actually add more cows into the system. It's very hard to do a study like that, so I won't be talking about that much. So this study by Bach et al. Was very interesting because they were able to put the same cows into a free traffic system, and then they crossed them over into a forced traffic system or guided traffic system in a study that lasted for several months, I think. Overall, they found that the cows had the similar milk production per cow per day in the two systems, so roughly 30 kgs of milk. However, the number of voluntary milkings was slightly higher in the guided or forced traffic scenarios, with 2.4 compared to 2.2. So perhaps the difference is not that high in the number of milkings per cow per day to have maybe resulted in an increased milk yield per cow per day as well. So as I said, both systems can work well, I think, in terms of getting enough milkings per cow per day and achieving good milk productions. In the pasture-based scenario, the original layout of pasture-based farms was a two-way grazing system. So the area was, the farm was divided into two large areas, and then two daily grazing allocations were made available. But there wasn't enough milkings being achieved per day, and that there wasn't a good distribution of milkings throughout the day. So Lyons et al. Looked into the impact of developing a third, adding a third area into what's referred to as three-way grazing, and it's what most commonly pasture-based farmers are operating with. And this addition of an extra area into the farm layout resulted in a 31% reduction in milking interval, 40% greater milking frequency, so number of milkings per cow per day, and 20% greater milk production compared to the two-way grazing system. So it was definitely something that was worthwhile, and it's why many farms now operate a three-way grazing system. And what they found as well was that the robot was being utilized a bit more constantly throughout the day, with less of these valleys at given times of the day. There's still valleys sometimes because there's some behavioral things for the cows as well, but there was a bit more even milkings throughout the day with this type of setup. Now, I'd like to go over the few studies that we've conducted here in Teagasc in our robot farm. We were operating a single Lely astronaut farm with the stocking rate of the farm varied depending on the year. At the time of the first study that I'm going to report, it was roughly 64 cows, but then in the previous years, it got even to close to 90 cows per one AMS, which was very high stocking rate. So the first study that I'd like to talk to you about is the effect of milk information and concentrate supplementation on milking frequency and on milk yield. This study has been accepted for publication in JD, so hopefully you'll get to see it shortly there. What we looked at was 2 levels of milk information and 2 levels of concentrate supplementation. The 2 levels of milk information were a frequent milk information, where we set the system to have a minimum of 3 milkings per cow per day and a maximum of 4 milkings. This is the way that the Lely system allows you to assign milk information. And this means that at the minimum, cows will get permission to milk every 8 hours, so to get 3 milkings per day. But depending on their milk yield, they get an incremental milk permission up to a maximum of 4 milkings per cow per day, which means permission to milk after 6 hours. So cows under this treatment would have had permission to milk somewhere between 6 to 8 hours from the previous milking. And then we had a restricted milk permission, which looked at a minimum of 1.7 milkings per day and a maximum of 2.5 milkings per day, which resulted in cows being allowed to milk again somewhere between 9.6 to 14 hours after the previous milk. And the 2 levels of concentrate supplementation, was a high concentrate supplementation regime of 3.5 kgs per cow per day, which might seem ridiculously low for some indoor systems, but Teagasc tries to promote a system, a low cost system where grass is the main feed source of the cows, and therefore this is the amount that is being proposed by people that know more about cow nutrition than I do. And we tested it against as well a low concentrate supplementation of 0.5 kgs per cow per day. And we wanted to see the interaction between the two of them. So we looked at the treatment combinations. So we had frequent milk permission, high concentrate supplementation, free milk permission, low concentrate, restricted, high concentrate, and restricted, low concentrate. So the cows in this study were randomly assigned to one of the 4 treatment combinations for a 5-week period. And then they were crossed over after that period into a different treatment for another 5-week period. And then they were crossed over again until all the cows experienced all the treatments. What we saw was that, the number of milkings per cow per day, there was an interaction between the milking permission and the concentrate supplementation. So the highest number of milkings per cow per day were achieved with the frequent milk permission, high concentrate supplementation, followed by free milk permission, frequent milk permission, low concentrate supplementation. And the 2 restricted milk permission settings having the lowest milkings per cow per day. So in this sense, maybe the milk permission had a higher influence in driving up the milkings per cow per day than the concentrate alone, but concentrate added to the milk permission definitely increased it even further. And then in terms of milk yield per cow per day, we found that cows allowed a frequent milking and supplemented with high levels of concentrate had the highest yield, and then cows with the restricted milking frequency and high concentrate supplementation had the second highest level. So concentrate supplementation was maybe driving up the milk yields per cow per day in this study. So even though concentrate supplementation can drive up and can contribute to more milkings per cow per day, it doesn't seem economical to use concentrate just to get cows to milk more often. However, you do get more milk for the cow, so that is something that needs to be balanced, and perhaps something that needs to be looked at more in the economical side of things as well. There's been other studies that looked at this effect, and for example, Bach found that there was no impact of offering high amounts of concentrate in the AMS in the number of milkings in an indoor system. Now, in these systems, they are already achieving perhaps a high number of milkings per day. Therefore, the extra concentrate allocation might not be doing much. Lazier et al., they found, and it was a pasture-based study, but operating a two-way grazing system, they found that milking frequency was not affected by a minimum milking interval, so 6 versus 4 hours milking permission, or the addition of concentrates as well. And in Ireland, there was a previous study as well that found that concentrate supplementation level had no effect on milking frequency in early or late lactation. So our study is the first one showing that concentrate supplementation and milking permission both combined can have a significant impact on milking frequency and milk yield with the settings that we used, of course. So just following on from that, I'd just like to look at this other study that I did titled The Effect of Teacup Removal Setting on Milking Duration. So the thinking behind this is if we can speed up each individual milking, perhaps the system as well can be better able to cope with extra cows in the system without being too stressed. So the strategies to reduce milking duration are still important to being explored. The principle behind this is that, for example, this is a typical flow rate curve during milking. And if, for example, we were to remove the teacups at 0.2 kgs compared to roughly 0.8 kgs per minute, we would have roughly a minute longer milking duration because of the way that the milking curve, flow rate curve looks like. So there's theoretical potentials for reducing milking duration in all types of systems, but in AMS systems as well. So in my study, what we looked at was 3 different teacup removal treatments. These were the only ones that were possible in this Lely AMS. There was a 20%, so when quarter flow rate dropped below 20% of the quarter's average milk flow rate, when quarter flow rate was below 30% of the average milk flow rate, or 50%. And for the 50% treatment, there was a 0.5 kgs limit, which meant that if the actual milk flow rate was above this limit, then the 50% removal setting was not triggered and was recalculated later on. So it was kind of impaired in its full application. Regardless, in this study, I found that there was somewhere between 8 and 9 seconds reduction in milking duration by using a 30 or 50% teacup removal setting compared to 20%. Now, this seems very little, but this was per cow, and with roughly 140 milkings per day, this could allow for 3 extra milkings per robot per day, which could accommodate 1 extra cow in the system. So there is something there as well to accommodate more cows in the system. But definitely, this is not a huge reduction. On the opposite side, Croxwell, I'm sorry if I'm mispronouncing this, looked at 0.06 kgs per minute versus 0.48 kgs per minute, and they saw close to a 1 minute reduction in milking duration with this absolute, milk flow rate setting. So it seems that a percentage-based study strategy is a bit more conservative, and but it had never been tested before, so it did provide good evidence on that. Another study that I did for my PhD work was looking at teacup removal settings at the slowest quarter level. So one thing we noticed was that there was always 1 quarter lagging behind, and cows were, they were almost done, but there was 1 quarter that kept on milking for a substantial amount of time. So what I wanted to look at was comparing a 30%, comparing a teacup removal setting of the last milking quarter, so the slowest milking quarter, of 30% versus 50%. Now, with these 2 settings, I did not find any significant differences on milking duration or box time with any other treatment. But I did find in this study that the slowest quarter had an average of 47 seconds longer milking duration, so almost 50 seconds longer milking duration compared to the second slowest quarter. So there's, at least theoretically, there's potential for reducing milking duration substantially by applying some sort of settings to the slowest milking quarter. Yeah, in terms of milk flow rate, there hasn't been control studies, I think, to my knowledge, on looking at, comparing different flow rates of the cows in the system, or how does that affect the overall efficiency of the system. But the study by Gargiulio et al., they pointed that, a flow rate of more than 1.8 kgs per minute could improve efficiency, could make those simulated or predicted gains be realized. Castro did not mention a particular level of milk flow rate, but they said that 0.1 kg increase would have substantial influence on milk harvested per robot per year. Hogeveen talked about a 2.5 kgs per minute milk flow rate. Doug Reinemann talked about a different concept, which was box average milk flow rate, and signaled that roughly 3 kgs per minute could be a good way of optimizing efficiency. And this is actually a good metric because it tells you about, what proportion of the time that the cow was in the box, she's, providing milk basically to the system. So the better the box AMF, the lowest the preparation time, the cow's entering and exit times, etc. So it could be a good metric to look at in the future as well. In our own experience here in Teagasc, we selected cows with the average milk flow rate of 2.2 kgs, and they look to be doing quite well in the system. This is purely anecdotal, so I'm sorry I can't provide more data, but we're reducing compared to previous years. We're reducing substantially the number of cows taking long time to be milked without any negative impact on milk yield in the system. So it was a good thing. And lastly, I'd just like to point you to Juan's model they developed with the Department of Primary Industries of New South Wales in Australia. They developed a kind of like the decision support tool based on his model. And I invite you to look at it and maybe input your data if you're robotic farmers, or if you're working with robot farms. You can enter your data here, so your number of robots, however many cows in milk you have, your average milk production, daily milk production, sorry, and your total labor available. And then the model will kind of show you the predicted physical performance indicators in the AMS, and you can compare if your farm or the farms that you are advising are roughly reaching that threshold. And it also provides a tab where you can look at the optimization potentials for the system, which I thought was really cool, and is start based. And in this situation, for example, they found that by increasing the number of cows per AMS by 5, that's the highest, the most beneficial measure to increase the milk harvested per robot per day. Then milking frequency as well is another strategy, and they mentioned milk yield, but increasing milk yield can be done by nutritional means or by increasing milking frequency, or etc. So it's kind of like an indirect thing as well. But I thought it was really cool, and it's not that often that we see open access models like this that could help us understand where we can make some adjustments to improve efficiency in our systems, I think, anyway. So finally, some challenges or some discussion points or some ideas that I'd like to throw out there. The potential that I've discussed so far, it's purely theoretical. I haven't seen anything being done on looking at the actual empirical potential of these farms. In my experience, and I'm not saying that this is the case for US farms, for example, sometimes the use is sub-maximized, but that may be a conscious decision by farmers. They may not be interested in having the highest occupancy rate or the highest number of cows per robot, but definitely we're seeing that there is more potential to be gained from this technology. I'd like to point, as I am a researcher, I'd like to point at the challenge in conducting control studies. If we wanted to add more cows into the system, it's hard. We'd have to do it perhaps in several farms, and that's a very difficult study to conduct, but it'd be a really interesting one to do. But there's a need for more. That being said, I think that there's a need for more control studies looking at, what's actually achievable besides the theoretical thresholds. And then there's the last bit of it is farmers' willingness and motivation. As I was saying before, some farmers just want some extra time of the robot being free for in case there's any problems, or there's a farmer's desire to to keep things a bit more relaxed. In Ireland, there's a few farmers that have taken on robots and have taken outside work as well, outside the farm. So maybe the way that the system is operating is working for them as well. And there's also the physical capability. So perhaps farmers don't have the possibility of having more cows in their herds due to land restrictions or space as well. So those are things to consider. But it is an interesting topic, a very broad one, and I think that more research is the common phrase, but it would be nice to see more of this research. So thank you. That was all for my part, and I'd be happy to answer any questions.
Thank you, Dr. Silva. Just a reminder, if you have any question, please type them into the Q&A. I have shared a link for a very, very short survey in the chat. Please click on that link and complete it as it at your convenience. So now I'm gonna share my screen.
Will I stop sharing? Oh no, you're okay.
Stop sharing. Wait. I'm gonna share the screen. So this is also a QR for the same survey. And now we are going to go over the questions. Give me 1 second. So the first question was about AMS pasture-based systems. You said that the motivation for cows to get milk is new pasture. So do you think that concentrate allocation in the robot is not necessary in these systems?
That's a great question. I sorry, I choked on a bit of water. I used to think that the knowledge before was that the concentrate in the robot was mainly to entice the cows to go in the robot once they have arrived to the milking shed, more so than moving through the system. But in our study, we did, comparing 0.5 kgs to 3.5 kgs, we did see that there was an increase in the number of milkings per cow per day. So maybe this is also a motivation for cows to move around the system. The promise of concentrate in the robot shed, in the robot itself. That could be something. There is something to it, I think. But on the other hand, in the very low concentrate treatment that we used, which was 0.5, we still achieved milking visits, very low, but still achieved some. So it's probably, it's not absolutely driving the cow motivation, but it could be a factor that could entice them more. But as I said before, maybe someone that's more into the economics of it than me could look at whether it's beneficial on the economic side of adding more concentrate just to motivate the cows to move around the system, or should we focus our efforts on other bits? But yeah, I do think that it does play a role.
Okay, next question now. Is automatic milk system means that animals have come to milk channel on its own in free range without concerning other animals, or just means mechanical machine system of milking?
I'm not sure if I understand this.
Yeah, me neither. I just copy and paste that.
Yeah, automatic milking systems mean that the task of milking is conducted by a robotic arm and a robotic unit. So it is the cows, there is no human involvement in the milking process, so the cows arrive voluntarily to a milking box. They enter that box, they are offered concentrate feed, and there is a robotic arm that attaches teacup into each of the teats of the cow, and then the milking occurs, and the teacups are detached automatically from each of the cows, and then the cows exit the robot box without any involvement of any humans in this process, which in conventional milking system, it is a person that has to go and get the cows, and then it is a person that has to attach the clusters. And yeah, so it's more labor intensive in that sense in conventional milking systems. I hope that was I answered the question correctly, but if not, I'd be
I
happy
believe
to
you did.
answer.
Thank you. Next question. Dr. Penner's group has some studies showing that increasing the AMS concentrate allocation in the robot increased concentrate refusal, but it did not affect milk yield. Considering it is well reported that cows do not eat all the pellet that is allocated in the robot, what do you think is driving the relationship between the concentrate refusals and decrease in milk harvest shown by Seward et al. In a
Yeah,
2018 study?
yeah, that's an interesting question. Actually, they don't they don't if I remember correctly from that paper, they're not able to explain it all that well, I think, because in the other study in Tremblay, they found a positive association between the uh, the refusal of the leftover concentrate and milk yield and milk harvested per robber per day. Um, I don't know, to be honest. I need to give this more thought if I'm going to answer this consciously, and I'd be happy to send you an email and respond to this in due time. But I don't really know for sure.
Next questions. Your studies of teat cover bowls are pretty cool. Did you assess udder health and milk quality?
Yes, we did look at. It was mostly SEC. We didn't do much work on bacteriology or anything like that. But it was SEC, and there was no impact on milk yield or on milk or on SEC at the cow level. And I would like to say as well that there's plenty of evidence in conventional milking systems as well that if you increase the cluster removal settings, there isn't any negative impact on milk yield or on infection levels or in SEC, up to a certain level, of course. I think my theoretical threshold or level would be if cows are past their peak milk flow rate and they're starting to decrease the flow rate, that means that most of the alveolar milk might have been harvested. The milk ejection reflex has kind of passed. Um, and maybe that's the point where you can stop the milking without having any negative impact on milk yield or an SCC. That's yet to be proven, but I know that in US studies they've done even up over 1 kg per minute cluster removal settings, and they found no negative impact. So you can really go very high in this type of settings. Now
Okay.
with,
Sorry,
sorry,
go ahead.
just thought maybe with pasture-based where the production levels are lower, you wouldn't go as high as 1 kg or over that, but in high producing systems, yes.
Got it. So, somebody asked if you could please share the link of the model that you presented, that website where producers can enter their different
Okay,
numbers and see what worked best for them, please.
I'll make a
And I
draft
will
right
also
now.
send an email with that link later. Next question is, what is your opinion about automatic batch milking systems and when would you recommend it?
Actually, yeah, I I actually just realized a few days ago that Zilaval had released a batch milking robot. I didn't know this before. When I was preparing the presentation is when I actually learned this. Um, and I think, well, I think that they can work okay, but um, to me, it kind of defeats the purpose of having a voluntary milking system, like a free-flowing system of cows arriving voluntarily to be milked. Now,
would you mind explaining a little bit? I think we only have one in the US. I don't know how many are in Europe. So some of the participants might not be familiar with that system.
yeah, so the batch robotic systems are basically where you bring the cows to be milked, or yeah, to a milking unit or several milking units. Those milking units could be one robotic arm being shared by different milking units, or a robotic rotary, for example. But the principle is that cows don't really arrive voluntarily, but they're driven towards the milking. And because maybe the robot, it may take, the robots are single box, uh, most of them, and or except for the rotary. The rotary could be a good idea, I suppose, but if it's a box system, you need a lot of boxes to be able to compensate for the time that it takes you to milk all those cows, compared to, for example, a parallel or herringbone parlor. So I mean, I'm sure they can work very well, but you might not see the benefits, for example, of the reduced labor. They might see some of it, but not the full extent of it, and there might not be the flexibility of it as well. So if you're batch milking, you're bringing the cows at certain times of the day, and maybe if the system is not fast enough to milk all the cows, cows may be waiting for a long time. Um, those are my thoughts in general. I'm not against it, of course, but I just some things that come to my mind.
And Angela Keeney has raised her hand, so I'm gonna give her permission to talk. Let me see if this works. Angela, you need to unmute yourself.
Hey,
Hi,
so
Angela.
just a comment. Here in US, in working with Boomatic, we have a double robot box. So we have two by those, and yes, we are doing more of those batch milking. We have a few in Europe now, and people are using more of that so they can manage the cows with less people. But yeah, it would be similar to a common milking process, but you don't have people you still have the feed inside if you want or not, and so you can use that or not. So it's a different way of managing with less people. That's more what people are using. Thank you.
Thanks.
Thanks.
That's really good input, yeah, from someone working with those. So that's good.
Yeah, essentially you still have to bring the cows to a holding pen, right?
I
And
suppose,
then
yeah. But then you don't have to worry about attaching the clusters and all that
yeah,
stuff as well. So
yeah. But I wonder too, like how hierarchy and all those kind of stuff play a role in there. Okay, next question. What's a practical advice for current AMS users to get more cows per box?
hmm. Um, there's definitely, I think, certain hours of the day the milkings tend to be quite low. So there's room for increasing the minimum number of milkings per hour in some of the hours, especially in the early morning, for example, or at night. Uh, and you can do that in indoor system by fetching a bit more cows. Now that results in, being the system being a bit more labor intensive. I think there's been some studies that increasing, the feed push-ups as well to motivate cows to move in the system a bit more and at different times. That could be with a robotic pusher as well. And in pasture-based systems, to try to manage your grass really, the grass allocation is key to make this successful and to achieve a steady stream of cows coming into milking. Well, once cows arrive to the shed or to the milking robot and they're committed to a pen or something like that, I think the robot theoretically can do at least 7 milkings per hour. So if we're looking at, 6 to it'd be like 8 minutes, a bit over 8 minutes of box time. I guess it depends on the milk production level of the cows as well. But in 8 minutes, you can get a decent, a cow with a high production milked. So optimizing the individual milking, perhaps by selecting for high flow rate cows as well, or looking maybe at a compromise between milking frequency and more cows per AMS could be a thing, provided it's not so low that it reduces your individual cow milk production per day too much. Those are some things that could be considered, I'd say.
Okay, thank you. Times per day allowed. Is there a way to determine what a cow should be at to improve her milk production?
What a cow should be at in terms of
When
what?
it comes to times per day, milkings per day allowed, milking permissions?
Yeah. Okay. Yes. That's a good question. Yeah. Well, the target, the different studies that I've looked at different targets. So it depends if it's pasture-based or lower milking frequency or not. That study that I showed you about Castro, he was saying that the target should be somewhere between 2.4 and 2.6 milkings per cow per day to be able to increase the number of cows in the system. In the study by Gargiulio, I think it was somewhere around 2.1 milkings per day. It should be enough to accommodate more cows in the system. But if you're looking to increase individual milk production per cow,
Based on permission.
based on permission, yeah.
Yeah.
So the permission settings, that also depends on the stage of lactation, and you want to have a frequent milkings in early lactation. So the permission in early lactation could be every 6 hours or so 4 milkings per day or so, and then start reducing afterward after you've reached peak or something like that. And that would be an efficient strategy, but perhaps not one that work in seasonal calving systems where all cows are in the same stage of lactation. Yeah, I think, and it depends a lot of whether it's pasture-based. In pasture-based, we're never going to get, I think, up to the level of, let's say, 5 milkings per day in some cows. Some cows might do it, I don't know, but it's not that common because the walking distances are much more, it's not really beneficial for cows to be milking more often either if they're not going to be producing more as well.
Yeah, they're just using the box more and taking the opportunity of other cows, right?
Yeah, exactly.
Okay, now we have another nutrition question.
Oh, geez.
Do you have any recommendations regarding pellet formulation, 1 or 2 formulation in terms of metabolizable protein? Sorry, with that word, I cannot pronounce it very well. Metabolizable protein and energy concentration of the pellets in order to optimize the nutritional supply to the cows.
Yeah,
Thanks.
I certainly I would have to excuse myself with answering that question. I am not a nutritionist and I wouldn't be able to respond which should be the adequate one. Sorry.
Yeah, no worries. We have my colleagues that were leading this webinar in the past. They did some nutrition webinars. The webinars were focused on nutrition for AMS. So I'll encourage you to visit our YouTube channel because all of our webinars are posted there. And if not, this might be a topic that I will be exploring in future webinars. So thank you for the question too. And I think we are at the end. We don't have any more questions. Dr. Silva, thank you so much for your time and a great presentation. Any closing thoughts for the topic?
Okay, and you putting me on the spot there.
All
Very
right.
good.
Well, in the
No, that's okay.
meantime, while you're thinking, if you don't have to, but I also want to thank my co-host, Cora Okema. She's also an MSU Extension educator, and she helped me to keep things moving with this session. So thank you, Cora. And
Yeah,
if you
so
go
yeah.
ahead.
So, well, first of all, thank you for all the questions. They were really interesting, and I'm sorry if I'm not able to answer some of them. I don't want to be lying to you or saying stuff that I'm not quite sure about. So I hope that's okay. But if you email me, I can certainly look it up for you and we can have a conversation then. Um, I think, I, I personally really like AMS systems. I like how the cows behave around the system. They seem a bit more relaxed. They have less, fear of the human interaction when you see them there. But and farmers, at least the ones that I've looked at here in Ireland, seem to be quite happy with the way that they're operating, and they don't seem to be too driven about the efficiency side of things. But maybe this is a misconception on my part. But I think definitely, even for the sake of it, there could be some gains done with very little extra, work on the farmer side and on the economic side that could yield further gains in efficiency and in terms of milk yield per robot per day. So I think there's plenty of work still left to do in this scenario. So I'm left with, after preparing the presentation, is that there's plenty of interesting things to keep looking at for sure.
Yeah, for sure. Like in every topic in dairy,
Yeah.
right?
Exactly.
We do have one more comment. Data analysis specifically for AMS dairy. Is there anyone specialized on that? Do you have any comments on that?
Data analysis for AMS dairy.
Yeah, maybe it's like an extension service or maybe
Yeah.
some consulting.
I know that Lely does, as part of their systems, they do manage a benchmarking type of group and international benchmark situations as well. Dilaval, when I was working there, which was a while ago, they were trying to implement something similar of some sort of farm management advising. I'd say the companies would have some people dedicated to farm management advising that could really help in analyzing data from the robots. Because that's the other thing as well. There's so much data coming out of the robots that sometimes it could be overwhelming. And it's important to have someone to sit there and explain this to you and seeing where can improvements be made, I guess.
Yeah, there's too much data. Maybe you're gonna need to work with different professionals. Like for example, if you're looking at the milk flow at the beginning of milking, that's something that I could help you, and maybe Pablo could help with something at the end of
Certainly.
milking or milk quality. But yeah, the amount of data collected by these machines are pretty impressive, and often ignored because it's hard to manage all that data. Okay, I think we're almost out of time. Thank you so much, Dr. Silva, for your time, for the presentation, for answering all of our questions. Like I mentioned before, this presentation will be shared on our YouTube channel. Dr. Silva, are you able to get that link for the...
I will. Oh, sorry. Yeah.
Yeah, if you
Got
can put it in the
distracted.
chat, that would be great. And if not, I will include it on an email where once the video is posted on the YouTube, I'll send you an email with the link. I'll send the link to the video. I'll send you again the survey. Please fill that out, and also with the with the link from Dr. Silva. Two more comments. University of Wisconsin-Madison has an AMS producer group. Yes. Yeah.
I should have known this.
And last question, is possible as humans involved in milking manually, they are able to detect mastitis issues. Can AMS handle this situation?
Yeah, that's a very good. I've put the link there. I hope you can see it.
Yes, yeah.
Yeah, I'm gonna type in my email address. Yes, so I mean, it is a different approach to it. Certainly, farmers are not longer looking at the cow's milk at every milking, so they have to rely on other sensors and indicators to be able to assess whether there's mastitis or not. But it does involve a change in the routine, I think, in terms of approaching mastitis problems. But definitely, you can achieve good levels of milk quality with these systems. So you have to rely on their indications, sometimes which are at the quarter level, so they're very accurate of, let's say, conductivity, blood, somatic cell count. Those are mostly at the cow level, but you can then investigate further. And yeah, the sensors sometimes they give you too many alarms, and they might, you know, be a bit over exaggerated, but you can work with them until the farmers usually develop a system in which they're comfortable with their mastitis management. It is different because you're not seeing the milk, as you say. What we're seeing as well, which is interesting. So, for example, I know that U.S. farms do regular milk recording, so they test for cow level SEC on a regular basis. In Ireland, we're seeing that many of the robot farmers are not doing that because they're trusting their indicators from the system. But I would encourage to continue to do those measurements because they're more accurate, in my view, at least.
Okay, now we're 1 minute past time.
Sorry.
Thank you so much, Dr. Silva. This was great, very informative, and everybody, please take the time to fill out the survey and have a wonderful rest of your day.
Thank you. Bye-bye.
Thank you. Bye.